In this problem, we're given the breaking strength of a string that's used to tie two blocks together and also to pull those two blocks upward with some unknown acceleration. So in part A, we're going to find the maximum possible acceleration of the blocks given the breaking strength on them, which is 100 newtons. And then in part B, we're going to find the tension between the blocks when they're moving at that maximum acceleration. So the first thing you have to figure out before you start the problem is which one of the strings has the bigger tension in it. So we have the upper string that we're pulling the blocks with, and then we have the string between the blocks. And that upper string is going to have the bigger tension because it's responsible for accelerating all 7 kilograms of mass here, while the string between the blocks is only responsible for accelerating 5 kilograms of mass. So we're going to get our maximum acceleration when that upper string has a 100 Newton tension in it. In other words, it's just about to give up and break. Now, the simplest way to proceed with finding the maximum acceleration is to collect these two masses into a single 7 kilogram mass. So that 100 Newton force that we're pulling up with is responsible for accelerating this entire 7 kilograms, but of course we can't forget about gravity pulling down as well. So we start to make a force diagram for this collected 7 kilograms of mass. And there's the 100 Newton force pulling up on the 7 kilograms. And there's the force of gravity. And of course, we can compute that mg just by subbing in the 7 kilograms. And then we're going to use 9.8 for little g. So now that the force diagram is done, we just apply Newton's second law. That's F net equals ma. And we're just looking at the y direction here. And our net force is going to be 100 newtons up minus mg pointed down. Now the mass is 7 kilograms. And g is 9.8 meters per second squared. And then over on the right-hand side, we have our 7 kilograms times our unknown acceleration a. So at this point, we can plug everything into a calculator. We take 100 minus 7 times 9.8 and then divide the result by 7. In rounding to our traditional 3 significant digits, we get an acceleration of 4.49 meters per second squared. So now we get to the second part of the problem where we want the tension between the blocks when they're moving at this maximum acceleration. And the simplest way to do this is to just focus on the 5 kilogram block at the bottom. It has one upward force on it, and that's the tension in the string between the blocks. And then of course it also has gravity pulling down on it. So there's our 5 kilogram mass. And again, now we know the acceleration is 4.49 meters per second squared going upward. There's the unknown tension pulling up on it. And there's the force of gravity pulling down on this block and calculated as m times g. So again, we apply Newton's second law. That's F net equals ma. Again, we're just looking at a y direction analysis here. And our net force is going to be T minus mg. I'm going to go ahead and just solve this symbolically this time. So T minus mg, and that's equal to ma. And this means T is computed as mg plus ma, but we can factor an m out of that to make the math a little simpler. So I'm going to write it as m times the quantity a plus g. So now we just sub in the numbers. So T is going to be 5 kilograms times a, which is 4.49. There's no room for the units here, but meters per second squared. And then g, which is 9.8 meters per second squared. And when I run the numbers on this to 3 significant digits, I get 71.5 newtons. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left. Or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.